So what's this hiding behind my TV here? Well, this is my ASUS RT-N66U that I have had now for about, actually, over 4 years. And it's been a pretty faithful routing companion. But as of late, the internet seems to crawl to a halt. And I thought, oh, it's, could be my internet service provider or related to the website that I was trying to connect to. But then when I pinged the router, the ping times would be horrible, standing only a few feet away from the router. Usually power cycling the router would just take care of it, or removing my device from being connected from the access point and then reconnecting it. I'm just curious. Let's take it apart. We're going to check the voltage of this loaded and unloaded first, just to see if the supply actually is doing what it's supposed to be doing. So I'm going to go ahead and plug that in. Have a little bit of tea, and let's get to opening this thing up. Let's take some screws off and see what we find inside. So no visible screws, but it looks like these little feet, yep, they come off. And there's screws behind here. The flat blade will work just fine. There we go. So it's just 4 Phillips screwdrivers. Single core CPU, Broadcom, I think 600 megahertz or 700 megahertz. The internet will know better than me. I've always found it quite fast. And it has 256 megabytes of RAM, which is more than most of the routers that I've seen. I think perhaps because, I'm gonna take the antennas off just so I'm not whacking them around. I think perhaps because it was intended, it had, for a while I had one of these at a startup that I worked for, where we tried using it as a network attached storage device, which it worked all right for a while, like a little SMB setup, Samba share, and it just, I think they put more RAM in it, a little bit more RAM, to try to handle if that was going to be used, but any large files would just kind of, it's not what it was designed for. So got all the screws out. I can feel that, I think this lid comes off. There's no sign of any seam in between the bottom of this and the top of this. So I'm thinking, oh, I think I see something. It looks like a little tab. There's gotta be a way in. There's always a way in. The screws definitely go up into here. There's probably some video on the internet that shows how to open this thing up in 5 seconds. It looks like I was right, and that this is the way in. What am I going to use? I'm gonna try this guy, I think, because he's pretty robust, and I've actually opened up. Yeah, there we go. Hopefully that's in view, and it's popping right off now. So I think there's just retaining clips all along, and that makes sense. There we go. Yeah, you can hear that sound of hard mechanical engineers' work to secure this thing shut. Actually, it's got quite a few clips on it to keep that down. It's pretty good. I don't know if the screws are even necessary? Maybe the screws are holding the PCB down. That doesn't want to open. Oh, it just reclosed it. Ah. Okay, maybe I should just go from the front, and we'll slide this way. And you gotta, oh, that just went inside. Well, sometimes you just gotta go with the flow. There we go. Let's see if I can just maybe pull on it and get the rest of it open. Nope, doesn't want to do that. So, I mean, I at least need to get that green piece back, because that's not gonna sit inside there. There we go. One more? Yay, there we go. Look at that heatsink. Jeez. That is not what I was expecting. That is massive. They did not lie. It is like spring retained. That is impressive. Is that an SD card slot? I think it's a micro SD card slot, or whatever, not micro. Yeah, micro SD card. Cool. Can that be used for something? I have to investigate. Look at that. Like 1, 2, 3, 4, 5, 6. 6. Yeah, it makes sense because they could do up to 9 antennas. I think the like gaming ones had like 9 antennas, and you could have more arrays of these and actually bump up the throughput. Programming header still intact. VCC RxTX ground, which is looks like a UART. Pretty cool. And I'll flip this back around. I guess just point out a few things that look interesting. DC coming in. Looks like a little bit of filtering right off of here because you got just a bulk cap, it looks like, just for that 19-volt supply coming in. There's your Ethernet, or I'm sorry, USB 2.0. That Ethernet coming in for WAN, and then LAN, the 4 LAN ports. All shielded, nice. This is all per Ethernet specification, they're all isolated. So Ethernet is isolated. So these are isolation transformers that are they're unity. There's no step up or step down. It's just an isolation transformer for each of these. They're isolated from conducted noise. 1410 HN36201CG, which looks like this is for maybe 2 of these. And then there's just the 1416 HN18101CG, which is just for the 1 port. Okay, everything else is covered up by a giant heatsink. I've got plenty of Arctic silver paste. I wonder if a little bit of thermal paste might help with the happiness of this thing. So let's look at how to get this board out. It looks... I think I released everything. Yeah, I did. So those 4 screws that were on the bottom, they weren't for this. Oh no, they were. I lied. They were. They went all the way through. But they used 4 screws to capture the panel, this PCB, and the bottom plate. Forgot to mention too, here's the row of LEDs, which is like a rubber, it's like rubbery. But let's get this out. That's good. We're gonna take that shield off, of course. Let me get it a little bit closer. Let's see if we can get a little closer. There we go. But all these inductors have little cutouts. And I wonder if shielding, I mean, it's all magnetic. So the flux, I wonder if it messes with the flux lines and stuff if you were to just shield the whole thing. Interesting. That's very interesting. Okay, we got 6 screws holding this thing down. Oh, and it's coming loose. Nice and loose. Cool. What do we have underneath here? I'm a little less impressed now. Why am I a little less impressed? Well, it looks... Wow, there's a lot of discoloration on the board. First of all, it's not been cleaned very well in manufacturing. Like the cleaning process after putting down, I would imagine this is an early rose. I didn't even look on the back if they declare rose on this. They do not, but I'm wondering if they were using lead-free solder. Yeah, I think I'm gonna clean this up a little bit first. Let's power it up, let's check the voltage, and then I might pause while I clean it. Now, there's a lot of exposed aluminum, I believe. So I'd be curious if anybody knows what this is, what's going on here, because it's, I would expect it to be all like this color, this nice white color, and not discolored like it is. Do a few quick tests. on it. All I'm looking for here is to make sure that it's not sagging when we turn it on below, say, 5% of whatever it's rated to, which is 19. Whatever I said at the beginning of the video that I've now forgotten. But we'll see what it is when it's open circuit. Okay, so we're looking for, it's off, so we should get 19 volts. This may just be the tab, the mounting tab. There it is. Well, let's flip it around so we get the right voltage. 19.27 looks good. So now we're going to power it up. When you power it on, the Broadcom chip comes up. I think it just runs at like 600 megahertz. It's not stepping up or down or anything. And then the power amplifiers, I think, are just, they just come up. Everything comes up and it's just like 11 watts. That's what it draws. So powering this up, I'm going to keep the probes on it while I power it up. Okay, so now we're going to power it up. Power supply looks good. 19.27 relative. There we go. Cool. So now we'll see when we turn it on what we get. 0.1 volts. It's sag 0.1 volts. No, the supply is fine. I was looking for like massive swing. That would indicate a bad capacitor or something going on with the switcher. I got a feeling, now that I'm thinking about it, that the leftover flux actually is what kind of did this to the board. Because some flux left over can be quite corrosive. And I'm wondering if that flux is corroding. So, Q-tips and 91% isopropyl alcohol to the rescue. Gonna clean this thing off, and then we'll come back. I have someone I know who has an ultrasonic cleaner. I'm wondering if perhaps that might actually help remove some of this discoloration that alcohol is just not going to take off. I'm not going to do that just now because I don't think that any of this really is affecting anything. This is just exposed plating it to sink heat off the board in areas that get hot. I'm curious. The Rose boards I know can use the copper fabrication, but I'm curious if this is like a first 2011, one of the first that was using the Rose, trying to use Rose compliant or use lead-free solder, and so they were using an aluminum substrate. But what I wanted to do now, that I clean off the back of this and got a lot of the flux that was up here with all the through-hole components and down here. It seemed to be around where all the through-holes were, and there were through-hole posts here that were soldered down, and you know, a lot of through-hole at the top and some through-hole at the bottom. So everywhere where there was through-hole, that's where I cleaned. But let's get that heatsink off. And what I see is that there are just little plastic retainers that are holding it in place. That's it. So let me just give this a little squeeze and let's see if they'll pop back through the board. Ends up being, well, I think it's going through there. Give another squish. Oh, there we go, one of them. Let's just hope they go back in again. I didn't irreparably break them. Then I will need to find replacement ones. They seem like they're standard. I'll squeeze a little higher up so I can give it a little bit of a push. There we go. You go. Come on. There we go. Through. And this one, just need to think a little bit more convincing. Gentle, gentle, gentle. Because these are nylon and they will break and end up properly. Oh, there we go. Well, that came out. They seem to pull all the way out. I'd rather not pull them all the way out, but flip it around. That one comes out. And that one comes out. Okay, cool. So nothing else should be holding this together, the heatsink on, besides, I would think, some thermal paste or a thermal pad, maybe. Maybe it's just a thermal pad. Nope, there it goes. So they're using thermal pads. The pad seems kind of wrinkly. And I'm really kind of disappointed that they didn't go the whole heatsink. Like, why just those areas? I mean, it must just be where the hot spots are. What if I just scrape it? Oh yeah, that comes nicely off. Okay. Just a little force is all it needs. So I'm going to clean this off. And what I think I'm going to do is use some thermal paste instead. I know, it's not really getting that hot. It looks as though these things might just pop off. And that there's a grid below them that is actually soldered to the main board. So I was thinking I might, yeah, you can see where they're kind of like riveted. I don't think it's riveted, but it's like press. It's pressed into place. Let's try the screwdriver again. This time, not pushing, not rotating, but levering it. Yep, there it comes. I see it coming. As he breaks the printed circuit board. A little more confidence with this one because I got the other one off pretty. Now this one has the Broadcom chip, I believe, underneath it. And it's funny, I was going to take this off, and I originally was thinking about, like, I had a 486 DX2 like passive heatsink. I thought, oh, I'll put that on there and that'll help this thing. Yeah, that's totally not necessary. So we'll just thermal paste the top of this, you know, just kind of for the heck of it. We'll reapply these guys, and then we will put the thermal paste back on, put the heatsink back on, reassemble the whole thing, power it up and see if it turns on. We are back after the lights went out when I was trying to get the solder paste underneath the heatsink here. And so that's been all reapplied. It looks really like it is holding nicely. All the spring clips have snapped back in. And so now it's really a matter of reassembling this back together again. For this effort, this is kind of where I'm going to stop. I think a little bit more of thermal connectivity just across the entire panel, as opposed to them just having the sill pad in two spots and then the heatsink actually being off the board by just a little bit, may have been contributing to it not fully spreading the heat out as well as it could have. May make a difference, may not. Just an experiment to see what happens. So to put it back together again, I'm going to disconnect the DC barrel jack. The shield back on, which I think flips around this way and is neatly lining up with all those 6 bosses. Hopefully you can see them the gold kind of popping through there. Cool. So we'll take our 6 screws here, and so while thermal paste I think is, I'll be the first to admit, is overkill for this, it might just help spread the heat out a little bit better. And these crusty pads were worn. Taking this, and I'm going to put it back into the bottom of the chassis with the shield side down. I mean, you can kind of see where it all lines up in there, and then it just kind of slops back down into place, I believe. Was that pretty much it? No, this has to go down a little farther. There it goes, and it snaps in. So there it is, back in the base of the enclosure. And really what's left is just putting the top of the enclosure back on. Just gonna press down on this and everything should snap back into place. And then we'll apply the screws. And cool. It's all snapped back in. It doesn't really. Does it need more force? I think it needs more force. Yep. Just lightly pressing on it did not snap it back into place. It needed a little bit more. Let's put the screws in, see if it draws down the plastic enough where I'm not pushing on it, because I don't want to be pushing on thin plastic. So that's back together. Before I forget, I want to put the little rubber feet back on wherever they ran off to. Going to power it up. All right, it's alive and it's back up and running. This is the end of the first part of looking at the hardware. In the next video, I'll be taking a look at wiping the firmware off of this, putting it into its recovery mode, and then walking through the steps of reflashing the firmware cleanly and restoring the configuration files so that you don't have to go through all of the individual configuration settings again. Finally, I will look at some tweaks and settings that may also help improve performance on this particular router. If you like what you saw, please give a thumbs up and subscribe, and I'll see you in the next one.